What are the surroundings in a closed thermodynamic system? Imagine you have a sealed container, like a bottle with a lid tightly screwed on. Everything outside that bottle, everything you can't see inside, is what we call the surroundings. In thermodynamics, when we talk about a closed system, the surroundings are everything outside the boundary that separates the system from the rest of the universe. A closed system is a specific area where matter stays put. No atoms or molecules can escape or enter through the boundary. But energy can still flow in or out, like heat or work. The surroundings are the environment that interacts with this boundary by exchanging energy. Think of the surroundings as the air, the walls of the container, or even the room where the container sits. The boundary itself can be a physical wall or an imaginary surface. It might be rigid or flexible, depending on the setup. For example, in a piston cylinder device, the gas inside is the system. The piston and the external environment outside the cylinder are the surroundings. If the piston moves, it does work on the gas or vice versa, and heat can transfer through the walls. The surroundings influence what happens inside the system because they can supply or absorb energy. If the system heats up, it's because energy is coming from the surroundings. If the system cools down, energy is leaving to the surroundings. This exchange happens without any matter crossing the boundary, which is key in a closed system. In real life, the surroundings could be the air around a hot cup of coffee, the walls of a boiler, or even the external environment of a heat engine. For example, in a bomb calorimeter used to measure heat from a chemical reaction, the chemicals inside are the system. The container and the air outside are the surroundings. Heat flows from the reaction to the surroundings, but no chemicals leave or enter. Knowing what the surroundings are helps us understand how energy moves in a system. It's a simple idea but very important for designing engines, refrigerators, and many other devices. It helps us see how energy transfer happens without matter changing places. This concept keeps things straightforward and clear when analyzing thermodynamic processes.